Okay. There's been a lot of talk about digital twin, and we're going to show you an actual project, and we'll show you the exact replicant in a digital twin. So I think it's pretty excited. But first, before we get into it, we got a couple housekeeping notes that we have to let everybody know. Next. Okay, all participants are muted, so you're not going to be able to talk, number one. Number two, any questions you have, please type it into the chat. We'll try to get to as many questions as we can at the end of the presentation. So when you have a question, please type it in during the course of the presentation. Number 4, the webinar is being recorded. So if you're on the webinar, you will get a recording as soon as it's completed. And you'll also receive a recording link that will be sent to the email address that you provided. And with that note, next. I'd like to introduce our presenter, Georgian. He's got over 20 years experience. And he's done some pretty large projects over the years, and he's basically presenting a really large-scale project that's applicable to all oil and gas projects. And he's presenting it, having used, our solution. And we'll talk a little bit more about the success that he had and the challenges that he encountered. So on that note, I will turn it over to Georgian, and the floor is yours, Georgian.
Thank you, Otto. We are going to see one of the biggest projects we had, and we finished this project this year, in fact, a couple of weeks ago. And this will be also excited for me to explain to you and to show you how we did this project at this magnitude. Next. So the project itself, it is related to an as-built model, as-built 3D model for 3 wellheads and 1 big flow station in Kurdistan, Iraq. And because we are living in a world of internet and digitization all over, everybody is using right now this technology to achieve faster the goals of the project. And we are using, we use 3D laser scanning and in combining with available engineering documents. But the things related to the project is that the cover space of this project was over 376,000 square meters. It is equivalent of 4 million square feet, which is quite big. In this project, the deliverables required by the client was in the first place as built PDMS model for all locations, and combining with PNIDs, which is meaning piping and instrumentation diagram, review and update. Of course, using in an intelligent model, it was required to update the PDMS database, PDMS being the engineering software required by the client to be applied in this job. Related to that model, the last output of this project was isometric extraction and clash report. We say in clash report related to clash detection between elements in the model. Next. Being a big project, we had few challenges in related to this one. The first one was related to the location. All these structures were located in Iraq Kurdistan desert, and of course we had limited access and high security logistics for these areas. But more important was that in 2020, 2021, we're living in this pandemic situation, so our traveling to the sites was banned, was not allowed to that situation. So we found solution to send a local company there to make everything possible from a scanning point of view, and we coordinate everything from here. The other challenge was the poor documentation, poor site documentation, and this was not updated and without reliable information. And another thing, it was the structure, unique structure. And of course, in the oil and gas industry, it is related to special structure. This is related to that. We are talking about, for wellheads, we are talking about pressures like 1,000 bars, which is incredible high. So from engineering point of view, it was a really challenge to make this project. Another aspect, it was related to previously development of the model, of the engineering documentation. Client closed the contract for engineering in 2018, and in the following years of plant construction, the documentation was not properly controlled from user point of view, and all the contractor or in different area use their own documentation and did not deliver on a certain point this documentation. The tight schedule. Everybody right now is trying and willing to ask very tight schedule. For this project, from the beginning, the project was for 4 months for as-built model and everything included for all 4 locations. Next one.
So, Georgie, and you completed all 4 locations, right?
Yes, we completed all 4 locations. Yeah, of course. Related to field data capture, as I said, we sent a local company with 2 Faro scanners for in each location. We had also challenging in this location related to access and related with explosion-proof areas and so on. Being all these areas having live production, but we succeeded in 3 weeks to make around 500 scans location for all these areas, and we receive this this point cloud in our office, because the fact that the client didn't want it to place magnetic targets into the site due to these magnets, we use paper targets all over these areas for a proper registration of the scanning. The point cloud, the plant point cloud, was divided in 5 working areas because all the point clouds was too large to be handled just by one team, and we allocate these working areas, point clouds, to an engineering team, including all discipline. When I mean all discipline, I mean from process, from civil, electrical instrumentation, steel structure, everything. Everything was contained in each team. Next one.
So, Georgie, and so the key was to have a good implementation plan to make this all come together, right? So you and the local scanning company had some sort of implementation plan that you guys followed, right?
Yes, and we had difficulties on managing the teams inside, and in fact, some areas was not properly, scanned, but we succeeded to make also the 3D modeling without the scan, and I will highlight this in the following minutes. This slide, it is important for me because this slide represents the most important challenge of this project. By the start of the project, we had some engineering documents in PDF formats or of DWG format, but we also had for the biggest, the flow station, the biggest one, we had a model developed, you know, at 80%, they said, the client said, and the evaluation was to work just 20% more to update the model to S-build. But in fact, when we received the point cloud, and here I highlighted two photos, one orthophotographic photo and one is you know, close photo related to overlapping of the point cloud with the actual old model and nothing fitting. It was a big challenge for us, but also for the client to see that in fact, the plant erection was not according with the documentation they had. But we took that in our hands and go forward. So this was the biggest challenge of that project. Next one.
So Georgian, your bid was based on, you know, getting about 80% of the work completed, right? So that was what your bid was based on, and that was not what was the case, correct?
Exactly, because having the model without any information from the site, we consider, and also with the declaration of the client, they said that the model is actually 80% from the plant, and we took it from that point. But when we receive the point cloud, we see other things. So clear the cross-checking of client with what was made in the field, it is related also with the scanning of that plant to see if everything is fitable with the engineering work. Next. At the beginning of the project, we start with this workflow, and I pointed here that it was at the start of the project. We had two different areas, the field work and the office work. The field work, in fact, it is the last scanning and the data registration as much as possible in the field. This is called for us data collection. When we receive this data collection by, of course, by you know, digital transfer or by hard drive, we receive by hard drive because on the digital transfer it's quite difficult. We receive it in our office. So in our office, the first stage, it is data processing. It's a registration of this point cloud, cleaning, and make all this dividing area for the teams. The project itself, the point cloud could be open in Recap and Navisworks for review between teams. And in this workflow, it was directly to you know, send it in a 3D modeling platform. And in fact, it is cross-checking between 3D modeling platform, PDMS, engineering software, and you know, checking between two monitors related to the point cloud and the model, and this was the first you know, workflow that we had. But unfortunately, this workflow was not even slightly suitable with the challenge we had that nothing was matching. So we had to find another solution. And because I'm always scouting on the internet solutions and you know, most suitable software that is applicable for me as an engineering company, we find you know, a great solution for us. And in this regard, I want to change to the other slide. The problem for us, it was the link between 3D modeling, between point cloud and the 3D modeling. And for every engineering company, this is a big issue, because what is you know, providing by engineering software is not quite optimized and suitable to use 100% with point cloud. Next. So during our discussion and scouting on the internet, we found Edgewise. We find Edgewise and we apply Edgewise in our workflow chain. And this is 100% what we are using right now and what we use for entire project that I'm speaking about. This for me is the optimized workflow, starting from data collection, data processing, and between data processing and 3D intelligent modeling, we insert this link, this chain for us, which is Edgewise. In Edgewise, we did 3D solid modeling, but we add the base intelligence for elements. And the most important thing, we had the chance to export to PDMS engineering software using their own internal plugin that is exporting directly in PDMS. For us, this was a salvation of the project. Next one.
Hey, Georgie, and I got to say that, you and I have been talking for close to 3 years about this, and you finally pulled the trigger and you went with Edgewise. And
yes, I wanted to go slowly, but
yeah,
but for me it was going to the mouth of the dragon directly, and I was using Edgewise in my workflow, and it was the best decision I ever had in from engineering point of view. I'm saying so from engineering point of view.
Yeah, I mean, I just got to say that the one thing that you said which stuck out was that the only regret you have is that you didn't start using it sooner.
Yes, of course. I had another projects before this one, and I use it in an old-fashioned way, because right now I'm saying about my old workflow, the old-fashioned way, and it was quite hard. It was quite hard, and in our office right now, in office, the work consisting in registration and combining with reviewing the engineering documentation received from the client, and then using Edgewise for piping, steel extraction, civil extraction, electrical instrumentation. We sent everything to PDMS in very organized way. This is very important, in the organized way. So after receiving these elements in PDMS, it was easy. I'm not saying easy, but it was not stressing, not easy, not stressing to model in PDMS and to allocate each element to proper database, to proper element, and to construct everything in an engineering software in PDMS according with client requirement. Of course, everybody is doing reviews right now online, so we made model review every week with the client. So it was easy, and we use Naviworks for this review. Next.
The only other thing I want to say, Georgian, is one of the things you're also going to show is the ground module, because the client was pretty impressed with what they saw. Yes. So I'm sure you'll go into that and show that.
I will highlight this. It was also impressive for us, not first for us, and because we were impressed, we show it to the client, and then the client was impressed. So it was very nice related to that aspect. So clear, we had big challenges with the project, but applying the optimized workflow, including edgewise in our chain of production, we come to very good results related to the project. One result was time saving, almost 50% from the time saving using automated feature extraction, comparing with alternative modeling solution what we used previously, and also cost. And when I'm saying cost and time, I'm saying the both are the most important words for us, but more important for the client. When the clients see the difficulties we faced related to matching the old model with the point cloud, we had a discussion with them, and he said, what can we do to finalize this project, but not to go over the budget of this project and the time. And we succeeded to do that using this new workflow, including edgewise. At the end, the client's words was exactly like this: we did not believe you can deliver the as-built model without major delays, considering the big challenges of the project. And they said congratulations. So I'm saying there are not so many clients that said congratulations, but they said, because they understood the challenges that we have concerning this model, this project.
So as a result, Georgian, you had mentioned that you're expecting more projects from the same client to come your way, correct?
Of course, we're expecting more. We are in discussion for another project, and even we spend, let's say, a little bit more to update this without increasing the budget. We are very happy that we kept a very good client, and our client is satisfied. And for sure, everything will come to a payback. I'm pretty sure of that. Next.
Hey, real quickly, I just want to throw out to everybody, if you have any questions, please put them into the chat and we'll get the questions at the end of the presentation. Okay, so please put your questions in there. Okay, thank you.
This slide is an interesting slide for me because it's tips and best practice. Related to this project, I just highlighted just 3 but if I'm thinking more, maybe I find another ones. But I'm just relying on the fact that many of the present elements available to be extracted on edgewise right now can be adapted to other needs. So you cannot find right now in edgewise junction boxes, electrical cabinets, instrumentation, but this is really not an issue. You can use edgewise to model this and to send it to an engineering platform and to put it in a certain database for each of these elements. So it is quite easy, and I will show you an example of that. And the other one, the laser scanning technology, is used more and more in industrial engineering projects. And the most important task, and we face it, is to find the best suitable link to connect point cloud with intelligent engineering design. And this is not easy. And if you send this and you find this link, and I find it in edgewise, and I receive not only a shape, but I receive also intelligence in that elements. It is best. It's the best for me in my workflow. Another important tip and best practice for me and for my company is the fact that we have no time to have training, to have 3 weeks, 1 month training for a particular software that we took and we implement in our workflow. So from that point of view, I'm really happy that using Edgewise, it was extremely easy. For me, is so-called software plug and play. So you can use this software very easy, and you can come to an output in a matter of hours, and very good output.
So Georgian, you're saying you don't need to start with a smaller, you didn't start with a smaller project. You went right into one of the biggest projects your company ever had and used Edgewise, got right into it.
So frankly speaking, I wanted to use Edgewise just for the 3 wellheads, because the 3 wellheads had no available 3D model. So it was from zero. So I took the Edgewise to use just in that 3 location. That 3 location, it is combining is 20 times smaller than the flow station. So, but we use Edgewise, and to not use Edgewise in the flow station. But in fact, the Edgewise was the winning solution for the biggest location we had, the flow station. And for that, please allow me to share my screen. And please, Otto, tell me if you see my screen.
I could see your screen, yes.
So this is the whole area covered by the project we had in the biggest location, the flow station. As you see, the whole area is over around 400,000 square meter. I'm going, this is the point cloud. I'm going to see an overview of the area. This was the biggest one, and I will go to see clear very fast the workflow we apply for this area. So you see here the point cloud, and in point cloud, using Edgewise, we succeeded to highlight tank. I will go down with my point cloud. Okay. So we made the vessel, we made concrete, we made pipe rack, we made structure, we made platforms. As you see here, everything you see here, it is exported and made in Edgewise. And look closer, when I highlight the point cloud, you will see that everything is fitting. Everything is fitting. It's sometimes it's very hard to define where is the model and where is the point cloud, because it is millimetrically, overlap. So everything is fitting. And look closer. After we did this in Edgewise, we exported in PDMS, and at the end we end up with this project. Everything it is fitting. So it was a very big work from our side, but we succeeded using this chain of workflow coming from point cloud, edgewise, exporting from edgewise all the elements from piping, structure, everything, and then import everything in PDMS and coming to this this one. Look here, I spoke about cabinets. Here you will see electrical cabinets made with edgewise. So for us was a great benefit because the junction boxes and the electrical cabinets in the plant was over 300 to 400, I believe. So it was very difficult to define this exactly as in point cloud, but we succeeded to make it from edgewise. We discussed minutes ago about the ground. So here it is the ground. It is well known that the ground cannot be modeled in any software, engineering software, because it's not required to be exactly like in reality. But we succeeded to make this, and if you look closer, the slopes of the point cloud, and look on the ground. The ground, it is here, and it's looking fabulous, and the client was really impressed to have also the ground present in the model. It is the first time in the history of that company to have this model and to have this ground related to the model. And it was 100% made in edgewise, exported from edgewise, and we use for triangulation, because we had a point cloud from edgewise, and we use triangulation on free software, which is it is how is call it MeshLab, and we use MeshLab, and it was perfect. It is a free software, and using MeshLab we had the chance to put this on the model. Another good aspect using the software was the communication tower. The communication tower was 100% made in edgewise, 100%. No other software. This was directly exported and imported to PDMS with intelligence. All the elements, all the E-beams, U-shapes, everything was exported to PDMS with intelligence. It is not just a shape, it's having intelligence, and all this platform, all this one have been modeled 100% in edgewise. The other thing, also elements like the wellheads, everything was designed in edgewise. And most important thing, we insert in the model the steel structure for everything, almost shop drawing. because we had the chance to do that in Edgewise, and it was easy for us to do it. Otherwise, you will not find these elements in a regular PDMS model, a process model. You will see just the shape, nothing more. But we did it even in a great things. So the water pits, Otto told me about the water pits. Yes, we did the water pits using Edgewise. Everything related to the water pits, it's 100% exported from Edgewise directly in PDMS. The sprayers, look at the sprayers. The sprayers that is made 100% in Edgewise and exported as is in PDMS, as is. And everything, it is 100% fitable with the point cloud and all the elements acquired by the client. I said something about missing elements, and I will say a few words about that, because it is very nice to see it. So we receive from the client this requirement. The generator and electrical distribution board are missing. We had, you see in the left side, the picture of the model, and this is the location. And in the right, the snapshot from the site. The generator was installed after the scanning, of course, and we had no documentation related to that. So we had that challenge. So frankly speaking, it was very easy to use to see that and to achieve that. I will hide this. You will see the point cloud. So we have nothing here because nobody go behind the containers to scan in their location, but we succeeded to do it in 1 hour. So this was performed in less than 1 hour. The steel structure, the paving, the cable tray, the steel structure support of the generator, everything was performed in less than 1 hour. And if I highlight the model, it is fitting exactly what is supposed to be. So check out again this picture and check out again the location. So everything was done very easy. But right now we are pro in doing that. Clear. So using this technology of laser scanning is not enough. It's not enough. The laser scanning is just a step to achieving an engineering model without having an I want to say perfect, without having a perfect link between point cloud and engineering platform. You cannot achieve in time and cost a project like this and the goals related to the requirement of the project. So for us was a winning project and a winning solution. So clear, we don't have any doubt that using the workflow that we have right now to have the possibility to tackle any kind of project, not only in the oil and gas. So this is applicable in any kind of projects, no? Food industry, petrochemical, also clear, also sites, everything. So everything was performed during 4 months, and then we had a review with the client, and at the end we updated the model at very at the last, at the gate and fence and whatsoever they wanted in a model. So I'm really happy about this project, and it was delightful time for me to speak about this one and to have all you around to see how we did it.
Okay, Georgian, on that note, we have a couple of questions, if you don't mind answering, from some
Yes.
viewers. One of them is, what's the configuration of the systems to run such a project level with such huge scan data? What was your configuration?
Yes. The biggest challenge is to run and to process the point cloud. This is the biggest challenge. If you are using point cloud directly into engineering platform, you need to have for each user a very powerful workstation, which is also very costly. In the other side, we use just one powerful workstation to process point cloud. We then process point cloud in EdgeWise, and when EdgeWise process the point cloud, we use directly the file from EdgeWise, which was very easy. It is open up in a matter of seconds, and we are using just EdgeWise for that. The configuration for the workstation, it is, let's say, a medium one. It is not a top configuration. It's a medium one, because we don't use point cloud directly to each user workstation, just the output, and the output have kilobytes or megabytes, besides the gigabytes, tens and sometimes hundreds of gigabytes of information related to point clouds. No, we send just kilobytes and megabytes to the users.
Georgian, another question is, how much error do you expect at the interface at the tie-in points of the pipe? How much did you expect?
Related to what?
To the tie-in points of the pipes?
Tie-in points. Yeah, okay, so we had the available documentation from the client, and we identify each tie-in points related to the piping, and this was divided and spread between the 5 teams that we had, and they handle each tie-in point at a certain level. But in fact, we didn't have connections with other project and platform to speak about really a tie-in. We had everything, so we didn't had problems with tie-in and interference with other project and other constructions. Everything was performed and rebuilt in this model from zero.
Another question, which is interesting, says that they couldn't model things like horizontal, vertical tanks and different types of ducting. So, and what they did was they dumped everything into Rivet. Used it in Rivet and then dumped it into PDMS. So the question is there any other software But in your case, you were able to model everything, so you didn't need another software, right?
So I use also Revit just for testing, because as I said, I scouted on the internet a lot of let's say solutions, but Revit, it is driven to to architectural side of the engineering, not on the process engineering. So you can use it, but for us it was not suitable at all. So, but in Edgewise we handle to model virtually everything, and in fact that I didn't have the ducting in this project. It is no issue, because Edgewise have a model called ducting, and you can use that model directly to model ducting. I tested and it's looking great. So I don't see any reason to use other software. In fact, that to find a software that it is making exactly the element that you need.
Hey, another question is, you completed this in 4 months. How large was your team? How many people were working on the project?
Yeah, so we had 20 people, but in a peak time, we had also around 30 in a peak. But the average, it is around 20 people.
Okay.
This is operators and also lead engineers.
Okay, so, and just for everybody, in the modelers, how many modelers were on the project to produce the modeling?
Didn't understand the question, please, again.
Okay, how many people were doing the actual modeling of the 28? Because some were engineers, they were doing other, comparing data, but how many were actual modelers?
6.
Wow. Wow.
Six people.
So 6 people in 4 months produced that model.
Yes, and they receive information from the engineers related to the documentation, to available isometries, to available let's say standards, and all that in order to construct everything. So we had a project manager. I was the project manager, but we had the most important person in the project was the PDMS admin or administrator. The PDMS administrator was the guy who made everything possible, because without a good administrator, it is impossible to handle the work in PDMS and to maintain the database without corruption.
Wow. How long have you been using PDMS, Georgian, with your company?
I use the PDMS as much as the client require. Unfortunately, I'm not, hiding the fact that PDMS is quite expensive. So I try to switch to a much more, let's say, not expensive software, but for oil and gas, most of the companies require PDMS. So I'm using PDMS from, I believe, 7 years in my company, and in the former company from another 10 years. Personally, I'm not a specialist in PDMS. I'm saying, and I'm saying out loud, so I'm not a specialist in PDMS, but we are using this platform due to requirement of the client.
Wow, it's pretty impressive. You mentioned earlier that the scope increased by 60%. Did the budget change too with that 60% scope, or?
Not even close. So in fact, the budget remained the same, the time remained the same, and when I'm saying saving time and cost, it is related to the other part of the work. So in a normal way, we could lose half of the time, another 4 months minimum in an old-fashioned way, or also increasing cost. But all this time changing and cost changing come, as a boomerang, also with the unhappiness of the client. So I avoided that. It was a stressing in the moment when I decided to do it, but I was in the same time very, let's say, very sure and confident that the new workflow, including age-wise, will be successfully, and it was.
Okay, another question is, well, let me just say, I could relate to that. I worked on a project in Iraq, and I was responsible for change orders. I generated over $100 million worth of change orders. So they certainly could change their mind very quickly on projects in Iraq.
Yeah.
Anyway, hey, and one more last question before time is up. It says, have you used any other control besides targets, like total station?
Yes, of course. So we had also total station, and the fact that the company who did the less scanning, they made also some total station survey in each location, and they made the registration, including that survey points.
Okay. Well, our time is up, and I want to thank everybody for attending this webinar. Any other questions that we didn't get to, we'd be certainly happy to answer them. If you do have any other questions, we'd be happy to answer them too. You could, write them in. Anyone that's on this webinar will get a recording as soon as it's ready. And all I could say is I thank you for your time, and hopefully the webinar was informative. And we look forward to seeing you on our next webinar. Thank you all.
Thank you, everybody. Thank you, Otto.
Thank you.
Bye.
Bye-bye.